Hello everyone, today's topic will be about greatest common factor and least common multiple. And the first of all objectives of this lesson, we will be able to understand find the greatest common factor of two or more natural numbers, and then understand the concept of relatively prime numbers, solve some problems, understand and find the least common multiple of two or more natural numbers, solve problems related to this, and use the properties of the greatest common factor and the least common multiple to solve problems. We have two topics, subtopics A and B. A is greatest common factor, or GCF. If say it shortly, we say GCF. So consider this problem. There are two classes of students, A and B. They study on a school course. Class A has 24 students and B has 30 students. The students need to form discussion groups so that the students in Class A are divided equally between the discussion groups, and the students in Class B are also divided equally between the two groups. How many discussion groups can we make? So we use here factors of these two numbers, 24 and 30. So as we studied in the previous lesson, we talked about factors, or we call it divisors otherwise. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. If we count, 24 has 8 factors, right? And the factors of 30 are 1, 2, 3, 5, 6, 10, 15, 30. 30 has also 8 divisors. So we when intersect them, we find the same numbers in both of these sets are 1, 2, 3, 6. These numbers have in both of them. Are in both of them. So therefore we can make 1, 2, 3, 6 discussion groups. And in fact, these are all called GCF, greatest common factor. So we say 1, 2, 3, and 6 are factors, and they are the common factors of 24 and 30. Let's go to the definition of this term. What is common factor? The factors that are same for two or more natural numbers are called the common factors of the numbers. For example, we already said that the common factors of 24 and 30 are 1, 2, 3, 6. So the next one, so why do we say greatest? What is greatest common factor? Why it's not smallest? We say that 6 is the greatest common factor. 6 is the largest number between 1, 2, 3, and 6. So the greatest common factor, or GCF, of two or more natural number is the greatest element in the set of common factors. We write GCF of A and B to mean the greatest common factor of A and B. When we write the greatest common factor, we write GCF and A and B in the brackets. That means the greatest common factor of A and B. For example, GCF of 24 and 30 is 6. We can use prime factorization as a short way. As we did in the last lesson, we did prime factorization. We factorized the given number into prime numbers, and we stopped there. So to find the greatest common factor of two numbers, we follow these steps. We write the prime factorization of each number, and we draw a circle, and we multiply the common factors. For example, we have to find the greatest common factor of 40 and 60. So we have to find the greatest common factor of 40 and 60. They showed us two ways, but the first way, I think it's the simplest way. So To know prime factorizations, to know the GCF of 40 and 60, we have to factorize. You see, factorizing 40 and 60 into the last prime numbers. We have to factorize 40 first. It's 2 multiplied by 2 times 2 times 5. And 60 is 2, 2, 3, and 5. So the only difference is here just one number, and other numbers are all the same. So it means that they have the same factors as 2, 2, and 5. And we multiply these three numbers. 2 times 2 times 5 gives us 20. So therefore, this number, 20, will be the greatest common factor of 40 and 60. So we write GCF of 40 and 60 equals to 20. Next example. Find the greatest common factor, GCF, of the following natural numbers. First one is 24 and 36. We have to consider these two numbers and find their GCF. So we're factorizing here 24 and 36 and dividing them by 2. We get 12 and 18. Dividing by 2 again. They're two numbers divisible by 2, right? So we get 6 and 9, but 6 divided by 2, but 9 cannot be divided by 2. So we divide by 2 only 6. We get 3 and 9, and now these two numbers is divisible by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. And again, divided by 3 gives us 1. So we circle the same numbers, 2, 2, and 3. We divide these three numbers, so we get 12. So GCF of 24 and 36 is 12, equals to 12. The next is B. Here we got three numbers, 24, 48, and 60. Even numbers, composite numbers, right? So we divide them all by 2, 12, 24, and 30. 3 of them, all of them is divisible by 2. We again divide them by 2. We get 6, 12, and 15. 15 is not divisible by 2, but others are. So it is 3 and 6 and 15 again. 15 is not divisible by 2, but 3 is also not divisible by 2. We divide 6 by 2 only. So we have 3, 3, and 15. Now we have three numbers all divisible by 3, so we get 1, 1, and 5. 5 divided by 5 is 1. We circle three numbers, the same numbers, and we multiply the three same numbers, 2, 2, and 3. 2 times 2 times 3 equals to 12. So GCF of 24 and 48 and 60 equals to 12. Now we have other term called relatively prime numbers. Now we all know what is a prime number. Prime number is a number that can be divided only by 1 and the number itself, right? As we said above in the definitions part. So what is relatively prime numbers? It is if the greatest common factor, GCF, of 2 or more natural numbers is only 1, then the numbers are called relatively prime. So when two numbers have only one common factor is 1 and nothing else, then they are called relatively prime. For example, 4 and 9. 4 and 9 has no common factors except 1. GCF of 4 and 9 is 1. Example 4.24, determine. Now please guys pay attention because you have been pronouncing words incorrectly. Not determine, is determine whether the following numbers are relatively prime or not. First is 14 and 27. 14 is 14 and 27 relatively prime. Now, to find if they are relatively prime or not, we again factorize them into divisors and find if they have any common factors or common divisors. So we divided them by 2 and then 3, 3 and then 7. There is no common factors of 14 and 27, only one. 14 and 27, the common divisor of these two numbers is only 1. So they are relatively prime numbers. The answer is yes, they are. Now we have two examples here. For example, this problem, 51 and 85, are not relatively prime numbers because they have a common divisor 17. So 51 is divisible by 17 and 85 is also divisible by 17. So GCF of 51 and 85 equals to 217. So no, they are not relatively prime numbers. The next section of this topic is least common multiple, or LCM. Common multiple. Now let's talk about only common multiple, not the least. So what is a multiple? A multiple of a number is the product of that number and any counting number. Now, the multiples of 2 are 2, 4, 6, 8, 10, 12. Whenever we multiply 2 by some number, we get 4, 6, 8, or 10, or maybe 100, right? So all these numbers can be multiples of the number 2. For instance, the multiples of 5 are 5, 10, 15, 25, 100, 1000, etc. So the multiples of some number should be greater than this number itself. Let's look at the definition. A common multiple of two natural numbers is a number that is a multiple of the first number and also a multiple of the second number. Did you get it? For instance, multiples of 2 and 3. The multiples of 2 are this set of numbers. They're all greater than 2. 12, 14, 16, 18, and the list goes on and on. And the multiples of 3 are 3, 6, 9, 12, 15, 18, 27, 30, 42, and then 90, yeah? And therefore the common multiples of 2 and 3 is started by 6. The common multiples, 6, 12, 18, 24. Now, what is least common multiple? LCM of two or more natural number is the smallest element in the set of common multiples of the numbers. So we pick the least number, yeah, the smallest number. For example, the least common multiple of 6 and 8 are 24, 48, maybe, and some other numbers too. We can write LCM of 6 and 8 equals to 24. The technique is the same. We factorize these numbers and find and circle the common multiple. Example, we're finding here LCM of 18 and 30. We did a factorization, and common multiples are 2 multiplied by 3 squared multiplied by 5 equals to 90. Now let's talk about the properties of the greatest common factor and the least common multiple. Properties of GCF and LCM. Property says us that A and B are two natural numbers, then GCF of these numbers multiplied by LCM of these two numbers equals to the product of A and B. It is not understandable by this property, so let's look at some examples. For example, GCF of 8 and 6 is 2, right? GCF, greatest common divisor. And LCM is 24. So when we multiply GCF by LCM of 6 and 8, we get 2 times 24 equals 47 or 48. Also, as the property says, A and B. Our A is 6 and our B is 8. As the property says above, equals to the product of A and B. That is a multiplication of 6 and 8. So 6 multiplied by 8 is also 48. 48 equals to 48. Therefore, GCF times LCM equals to A multiplied by B. That is 6 and 8. We have some practice problems here. Now find the least common multiple of each group of natural numbers.